today's class. Now, last class we have discussed already a single ramp A to D converter, counter type A to D converter. Also, we have completed a successive approximation A to D converter. Today, we will discuss a flash A to D converter. Flash A to D converter. Just understand this. I have 8 inputs, 7 inputs, 0 to x0 to x6. And based on whichever is 1, okay, x0 is 1, only y0, y1, y2 I will get 0, 0, 1, it is a priority encoder. If x1 is 1, you will get 0, 1, 0, like that. I want you people to copy down this table and this diagram priority encoder. You can leave it, at least priority encoder you can copy down later because it is a part of a flash A to D converter. Now you understand this, you have a maximum 2 minutes of time. In our flash ADC, if x2 is 1, by default x1 and x0 will be 1 in our case. X is a don't care, but in our cases, flash ADC, if I say x4 is 1, by default x3, x2, x1, x0 will be high. And if I say x6 is high, automatically remaining will be high in our flash ADC circuit diagram. The slide also. Now, let us go to the op-amp comparator. So this compares Vi and VID. If Vi is greater than VID, automatically X will be high. If Vi is less than VD, and automatically X will be 0. Just copy down this because this circuit in previous priority encoder is a part of your flash A to D converter. Whenever Vi is less, output will be low. If Vi is high, output will be high. So this is a flash ADC, n-bit flash ADC. Op-amp needed are 2 raised to n minus 1. And V reference is the voltage I am giving, a full scale input signal voltage. And code resulting from the comparator is converted into a binary code by encoder. See, I want you people to copy down this. This is a priority encoder. And op-amp connected, I have a resistor R. All you can take R. And voltage, if I am applying say 8 volts, automatically I will get 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, 6 volt, like that. And operation we will see in the next slide. Now I want you to copy down 1 or 2 points from this slide. You have 1 minute, or you can take more than 1 minute. Then we will go to the operation with some example in the next slide. Hope most of you have completed copying this. Anyway, this a circuit diagram will be there in the next slide also with operation. The simplest example I have shown you so that everybody can understand. There is a saying, picture tells 1,000 words. V example, V now giving a 3.1, 3.2 something voltage. V reference is the 8 volts. So when I give like that, 3 volts. So these 3 will give the output. Because of that, output of the priority encoder will be 0, 1, 1. So try to understand. Very simple. Understand, when I have given this as 8 volt, this will be 1 volt, this will be 2 volt, this will be 3 volt. And this will be 4. And this is 4 means more than this. Automatically this will become low. Like that you understand all the op-amp and try to copy down this. You have a 20 seconds time. Let me show you another example so that you can understand easily. So this is a 6.3 something I am giving. So when I am giving this V in 6.3 volts. So it is 6.3 but this is 6. Up to this it will be high. If this is giving high means remaining will give automatically high and this will be low. So therefore you will get a 110 as a output. Try to understand. Take another 30 seconds. If you want you can copy down. First you understand these voltage levels at this point. At this point, V is a 8 volts. So fill that and understand. It will be 1 volt here, 2 volt here, 3 volt here, 4 volts here when V equal to 8. Once if you understand this line and op-amp output will be either 0 or 1, it is very easy to understand. Anybody want to say why it is called as flash ADC? All of you know flash means what? Why it is called as flash ADC? And it is the fastest ADC. Very good. Patil is telling something because it is not storing the data permanently. Okay. as something is better than always nothing. Thank you, Pooja. Compared to other ADC, you have already discussed some other ADC. Compared to that ADC, why this is called as flash ADC? You have taken a single ramp ADC, you have taken another ADC, successive approximation you have taken. Why it is called as flash? All of you know flash, suddenly, within no time, when you apply the input here, suddenly you will get output here. No charging, no discharging, no counting, nothing else. Simply give the input, take output. Give the input, take output. It is the fastest ADC, whatever the ADCs we have discussed so far. This is the fastest A to D converter compared to any other ADC, whatever we have discussed so far. I simply give the input. So operation is also very simple. Within no minute I'll get output. No charging, no discharging, no counter, nothing else. Simply give the input, get the output. That's all. That's why it's called as a flash A to D converter. It is the fastest A to D converter. Let me go to the next. Thank you, Pooja, for your answer. So far we have discussed a single ramp, counter type, successive approximation, flash. Now the last one is remaining dual slope ADC. And it's very I used to take a lot of time when books were very less. So at that time I prepared the video and I uploaded. More than 20,000 students have seen this dual slope ADC. And in these PPTs I have made still easy. Anybody can understand. Like that I have prepared the PPT. So we will discuss the dual slope A to D converter. You have a time 2 to 3 minutes. I want you people to copy it out neatly. A common mistake most of the students they do it while copying. Please compare this in your notebook. T1 should be more compared to T2, or T2, either this or this should be always less than T1. If somebody has taken this time period is more than T1, then it is a completely wrong. And they may have joined these two like this. This is 100% wrong. These two are parallel lines. These two are parallel lines. So if somebody has done the mistake, please correct it in the exam also. Don't do that mistake. Remember, T2 will be less than T1 and these two will be the parallel lines, but these two are not parallel lines. So the whole working of the dual slope A to D converter will be understood only from this. And whether you answered or not, in the exam we'll see this and we'll give the marks. First we'll see this. If it is wrong, 100% will come to know student has not understood anything. So now let us go to the operation. It's an indirect ADC. It is an indirect ADC. Speed is very low compared to any other A to D converter we have discussed so far. Accuracy is very high compared to any other ADC. And V reference is always opposite polarity compared to the V in. Please observe carefully. And S is switched between V in and V reference, which is controlled by MSB overflow. Please understand, S is switched between V in and V reference. I mean to say minus V reference. It's controlled by MSB overflow. All of you know overflow when it will happen. When all become 1, then it will become 0. No? We call it as an overflow. So copy down the slide. You have a 2 minutes time. Now, V in and V reference are converted into time periods by using an integrator and then measured by means of a counter. Those are converted into time periods, then it is measured by using a counter. So observe carefully. V in and V reference are converted into time periods. How? Using an integrator. Then this is measured by means of a counter. Copy down. You have a 1 minute of time. Integrator generates a ramp. All of you know when I give the DC voltage it will generate the ramps. And overflow will occur automatically after some time. A switch position will change from VI to the V reference. And whenever V reference becomes greater than VI, V reference we choose such that its equivalent is digital. Whatever we take zeros and ones combination will be little bit more than the counter capacity. And VC depends on the VI voltage. Please try to understand what I am telling. So positive I am giving here, this will become positive, this will become negative, this will become positive, and clock will reach the counter, counter starts counting. I repeat, please try to understand. This Vi is positive, capacitor this terminal is positive, this is negative, again this will become positive, and gate will work, clock will reach, and counter starts counting. Please copy down, you have a 1 minute of time. This is high, positive, this becomes positive, this becomes negative, and gate conducts, clock reaches the counter, counter starts counting. Now let me go to the next. Now this slope, whatever you are observing, it depends on the Vi. So V1 is directly proportional to the Vi. How much capacitor charges, sir? It depends on Vi. If a Vi is more, charging will be more. If Vi is less, charging will be less, but it will charge a little. And after 2 raised to n clock pulses, counter will overflow and switch connected to minus V reference. Instead of Vi, it will connect it to V reference once the overflow occurs. And now counter starts counting from 0 again. Whenever overflow is there, all 1. Again, when you give one more clock pulse, it will become 0. And again, it will start from 0001, 0010, like that it will continue. And this time period we call as a T1. And I am asking, is a T1 is constant for any given input or not? Observe carefully, try to understand. This overflow is there. Because of this overflow, switch will be connected to the minus V reference. Copy down, you have a maximum 2 minutes of time. Why the T1 is constant? Try to understand, because irrespective of any voltage you give, there will be small positive voltage, and this will remain positive only because it cannot discharge through this positive source neither on op amp. So therefore this will be positive, clock will reach continuously the counter, counter will count. Once overflow, then only this switch position will be changing. So whenever there is an overflow, that time, so this connection will be to the minus V reference. So therefore T1 will be constant. Now see charges towards opposite direction whenever the connection is to the minus V reference. And VOI will become low, this voltage will become low, hence this AND gate disables, clock will not reach the counter, counter stops counting. So please try to understand, this becomes 0. So therefore this is a low, and AND gate disables, and binary counter stops counting. You have a 1 minute time, copy down and understand. And remember, T2 is not fixed, because how much it has charged depends on that. It will take a discharging time period. Based on that, a counter will be counting. Please try to understand, take a 2 minutes and copy down. So counter stops at T2 time period, and T2 depends on the V1, how much it has charged. V1 depends upon the Vi, how much you have applied. I can say T2 is directly proportional to V1, V1 is directly proportional to Vi, means T2 is directly proportional to Vi, hence the count depends on Vi, what you have applied. Copy down these 3 lines and try to understand. So remember, charging time period will be equal to always discharging time period, and this I can write Vi by R1 C1 equal to V reference by RC C1 into T2, and R1 and C1 in both the time period, charging or discharging, you see R1 C1 is common, so therefore those two can be cancelled, and you will get a T2 equal to Vi by V reference into T1. T2 is always less than T1, this is very important, and T1 equal to 2 raised to n pulses. T2 is less than 2 raised to n pulses. Digital output, what I get, it depends upon the count plus second into Vi by Vr into T1 time period, how much it has charged. So copy down, try to understand. Take 1 or 2 minutes. So far, we have discussed single ramp ADC, counter type ADC, successive approximation ADC, flash ADC, and just now we have discussed the dual slope ADC. You have 2 minutes, go through all, and you can have if you have a doubt, you can ask in the chat box. We'll spend a little time. If you need, even I can revise also. Take 1 or 2 minutes, go through all the A to D converters. See, the why we go for a to D converter, that I explained. Everything in the world is a temperature, speed, position, everything in the analog, that we convert into digital. Then we do the processing. Then again we need a back analog. So therefore A to D converter and D to A converters we use. This is one simplest example I am talking. This will be stored in the, now converted into digital, that will be stored in the computer. Again I will make use of that. Again I will upload in the YouTube, and again from YouTube we convert. When you download D to A converter we use, and sound I will listen again back. And 1 bit ADC we have discussed, and resolution means, quantization error means we have discussed. Types of ADCs we have discussed. In that first one is a single ramp ADC, and after copying this we have a discussion. 4 volts if it is given, ramp is increasing, and because of this initially counter is 0, it will start counting as the input is high compared to the ramp generator. Clock will reach the counter will start counting, and at some time when input becomes, ramp voltage becomes greater than 4 volts, that time your op-amp will give the low and it disables, counter stops counting, then reset will be sent to the counter, and before that latch will be set signal. And similarly we have discussed another one as counter type A to D converter. There also we had a discussion. Only the difference is we have used the counter here. So 0 volts initially, this is a high, clock will reach the counter will start counting, and this will be given to the DAC will convert into bits into voltage, that is given to the comparator. And when it becomes greater than 4 volts, that time this will become low, clock will not reach the counter, and because of that it will stop counting and it will be latched. This also we have discussed. And after that we went to the third A to D converter. I think that is a successive approximation. A lot of slides are there, it's taking a little time. We discussed about the binary search. We every time half we will do it, so that time taken will become very less. After binary search discussion we discussed how a binary search works and how we use it for a successive approximation A to D converter. So these are the points which you have gone through, and this is a block diagram. Only the difference is counter is replaced by just a successive approximation resistor. Remaining operation will be almost same that we have discussed in the previous classes. So SOC is given, and automatically SAR will make a MSB high, remaining bit 0, that will be converted into voltage by the DAC, and DAC output is taken, and the comparator will get that, and comparator will compare that, and based on the output voltage of the comparator, now this SAR will decide whether to keep that as it is, whether to set next MSB or not. Based on that it will work continuously until unless last bit is checked. So these things we have discussed in the one example also we discussed, and after that we discussed the flash ADC today, and priority encoder 1 bit flash ADC we have discussed, and 2 examples we took it. If it is a 3.1 volt, how it will become 011. Another example also we took, and whenever the input is say 6.3 volts, how it will become 110. This was shown to you people, and it's called as flash because within no minute we'll get output, and it's the fastest ADC whatever we have discussed so far. The last we have discussed is the dual slope, very interesting, and sometimes it's difficult to understand because it takes a time to convince somebody. Why it is called as indirect? Because we convert the voltage into time period, then we do the comparison. Then switch is controlled by the MSB overflow. This is one important point we have to remember. And then we have discussed a VN and V reference are converted into a time periods using an integrator, and then those will be measured by means of a counter. So these are the points we have discussed, and hope all of you understood the dual slope also. And this one main concept is the slope here will change, but slope will remain same here because VI changes here. It's one important point, and this completes your A to D converter subtopic. If you have any doubts, you can ask now. Advantages of a dual slope ADC: low cost, not affected by temperature or any other things, and the speed is very low compared to any other A to D converter. This is a disadvantage. You have a 1 minute time, you can copy down this. So digital to analog converter. Again, for this digital to analog converter, we give the zeros and ones as an input, and some voltage we are going to get as an output. A block diagram you can copy down. B0, B1, B2 I'll give as an input, and output I'll get some voltage. A D to A converter in its simplest form uses an op amp and either binary weighted or auto OR. We have two types of D to A converter we are going to discuss. One is a D to A converter with a binary weighted resistor, and there is a D to A converter with a R to R resistors. Copy down these two titles, headings, and one by one we'll discuss. This is a D to A converter with a binary weighted resistor. We have a R by 2, R by 4, R by 8, or you can take a R 2 R like that also. And in this diagram we have taken R by 2, R by 4, R by 8. Copy down this, you have 2 minutes, and we'll try to discuss how this digital will be converted into analog voltage. Thank you. Many students are typing now, they have completed copying work. See, because we have a use an inverting terminal, output will be automatically a negative voltage, not a positive voltage. So therefore, I am getting a negative voltage based on the binary combination. Whenever I have connected all switches, more current will be there, therefore more voltage will be there. So I will get a negative voltage because I used the inverting terminal. Copy down this, and the operation we will discuss. See, the number of binary inputs is 4. Hence, we can say a 4-bit converter. Number of input combination I can have 0, 0, 0, 0 like that. 16 combinations I will get. Analog output should have 16 possible values. And B0 to B3 used to simulate the binary inputs. I will do the connection, I will remove the connection. So this is what I am doing it. Copy down these 1 or 2 lines. Then we will see the equation. Time is 10 o'clock. I didn't see it. Anyway, you have to attend the next class. Thank you for attending the class, and I'll be here for another 5 minutes. If you have any doubts, you can ask me. Have a good day. Take care. Be safe. Thank you.